Hello, in this video we investigate the following problem on the topic of limit of a function. Determine the following limit. Limit of 2 times x squared times sine of 1 over x all over square root of x squared plus 1 minus x as x goes to minus infinity. Pause the video at this point and give it a try. On the next slide, I will show you the final answer to the problem. The answer to the problem is minus 1. If this is not the answer you got on the first try, pause the video and give it a second try. Okay, you know that in calculating any limit, first we need to know what type of limit we are facing. For example, roughly speaking, let us replace x with minus infinity. So what happens in the numerator if I do that? So minus infinity to power 2 becomes a positive infinity. When you multiply it by 2, it remains positive infinity. Okay, but 1 over minus infinity is infinitesimal, meaning 0, and sine of 0 is 0. So when I multiply it, it becomes 0 times infinity. So the numerator itself, as we talked during the lesson, is an indeterminate form. So the numerator, roughly speaking, is of this type, 0 times infinity. Okay, but what about the denominator? If I replace this x with minus infinity, raising it to power 2, it becomes positive infinity, and 1 is negligible compared to positive infinity. But when I take a square root, it becomes positive infinity. And then x is minus infinity. Because of this minus sign, I will have plus infinity, so it becomes infinity. So roughly speaking, this limit is of this type. Okay. But of course, you know that I cannot use the theorem of division of limits because the numerator is still not a fixed number. That is an indeterminate form. Of course, this is something that you need to write to convince yourself about the type of the limit. This is not something legitimate that you need to write on your paper if you are doing an exam. Okay, but this motivates you how to act. Okay, so if infinity was a real number, then of course this infinity and that infinity are gone. Okay, but you know that here there is a little bit difference between this infinity and that infinity when it comes to this strength. Why is that? So if you remember, when I got this infinity comes from the fact that I raised this x to power 2 and minus infinity to power infinity. So in principle, this is a infinity of higher order, yes, because this infinity is of infinity to the power of 1. These are just roughly speaking things, and this infinity is of power 2. Okay? So usually if you have this situation, the numerator dominates. So to make these infinities of the same type, so let me write this for you. Might be it is a little bit easier to understand. So what I told you that the numerator is roughly speaking of this order, 0 times infinity to power 2, and the denominator is just infinity. Okay, to make these two infinities of the same order, because by the experience you got during the lesson is that if you have a fraction of the type infinity over infinity, and if these infinities are of the same strength, then we are more or less hopeful to get a finite number at the end. So to make these two infinities of the same type, this might motivate you to do this trick, to write it as 2x divided by square root of x squared plus 1 minus x multiplied by x sine 1 over x. So what was the benefit of doing that? We can see this. Of course, this part is still minus infinity times 0 of the type 0 times infinity. The numerator is infinity, the denominator is also infinity, but this time the infinities are of the same strength because they are of the first degree. Okay, so hopefully the limit of this part should be a finite number, and the problem will be, can I calculate this limit If you do this part and you use your memory, you saw that we solved this problem during the lesson, but when I was solving the problem, x was approaching the plus infinity, but they are very similar. So now this means that by this kind of motivation, you are being guided what to do. So we calculate this limit based on the experience we have. We know that the limit will be a finite number. We calculate this limit based on what we learned during the lesson. We know that this limit should exist. And then if this limit exists, and if this limit exists, we know that the limit of the product also exists, and it is the product of the limits. So that's what I'm saying, that so you need to think somehow around these lines to be able to understand what to do. Okay, so now we are more or less hopeful that we can solve the problem. So let me calculate the limit of 2x over the square root of x squared plus 1 minus x as x approaches to minus infinity. From the experience you learned during the lesson, I just copy and paste the numerator, but in the square root I factor x squared out, so it becomes x squared 1 plus 1 over x squared, and then minus x approaches to minus infinity, and then this becomes the limit. I copy and paste the numerator. Okay, but now what happens? The square root of x squared is always absolute value of x, so I will write it as absolute value of x, and then I would write 1 plus 1 over x squared under square root sign, and then minus x approaches to minus infinity. So now I ask the question, can I get rid of this absolute value sign? Of course yes, because when x approaches to minus infinity, I am sure that this x is negative, so I can remove the absolute value sign. But if you remember, we have to put an extra minus sign there. So this becomes 2x. I copy and paste the numerator. Instead of absolute value, I put minus x square root of, square root of 1 plus 1 over x squared minus x approaches to minus infinity. So now, as you can guess, in the denominator, I factor a minus x out. And then what is left for me in the pair of brackets? Square root of 1 plus 1 over x squared plus 1. And I copy and paste the numerator, and x approaches to minus infinity. So now what I do, this x and that x are cancelled. In the numerator, I am left with, so let me change my color, sorry. I am left with 2, and in the denominator I have a minus, and I have a square root of 1 plus 1 over x squared plus 1, x approaches to minus infinity. Okay, x approaches to minus infinity, so this part 1 over infinity goes to 0. So I have a square root of 1, which is 1 plus 1, 2. There is a minus sign, minus 2. So 2 divided by minus 2 is just simply minus 1. Yes? Okay. Now we calculate the limit of the second part. So I want to calculate the limit of x times 1 over x as x approaches to minus infinity. Based on the experience we got during the lesson, I just introduce a new variable, capital X, equals to, semicolon equals to means by definition is equal to 1 over x. It means that I am introducing the capital X to be 1 over x. Okay, but then you remembered what I told you during the lesson. Now you have to rewrite your limit, but you have to get rid of little x in favor of capital X everywhere. So we will do that. So the first thing I want to know is that what happens for capital X as little x approaches minus infinity. Okay, if little x approaches minus infinity, this would then imply that capital X goes to, roughly speaking, 1 over minus infinity. So it becomes infinitesimal. In other words, capital X goes to 0. But to be more specific, it goes to 0 from the left-hand side, yes? And then of course, if capital X is 1 over x, little x will be 1 over capital X. So this means that now I can rewrite this limit. Instead of little x here, I can put 1 over x. Instead of 1 over x, I can put capital X. And instead of saying that little x goes to minus infinity, I will go that capital X goes to 0 from the left hand side. So this becomes the limit of capital X goes to 0 from the left, 1 over x sine x. So let me write it in a more familiar form. So instead of writing 1 over x times sine x, I can simply write sine of x over x as x approaches to 0 from the left hand side. But of course, you know that the limit of sine of theta divided by theta itself when theta goes to 0 is equal to 1. This is a very famous limit we'll learn during the lesson. Of course, if this limit is equal to 1, it means the left limit is also 1, the right limit is also 1. So this means that this limit is 1. Yes? Okay, so now the limit of this part is minus 1, and the limit of this part is 1. So it means both limits exist, and I want to find the limit of the product. So the answer will be the product of the limits. So the answer to the main question is minus 1 times 1. So the question mark itself is equal to minus 1 times 1, which is minus 1. So that is the answer to this limit. I hope that the video was useful for you. Until the next video, be safe and goodbye. Thank you.